Alright, hello everyone, my name is Abraham. Well, today we are going to discuss chemical equilibrium, and mainly we will compare and we'll see the importance of reaction question as well as K equilibrium. Now, remember that both these have the same form, meaning K means concentration of C to the power of C times concentration of D to the power of D over concentration of A to the power of A times concentration of B to the power of B. And for Kc, it is the same, but remember the concentrations are at equilibrium. So I'm going to put equilibrium simply to differentiate Kc from Q. The power of C times concentration of B to the power of D over concentration of A to the power of A at equilibrium times concentration of B to the power of B at equilibrium. So remember, both have the same form, but the difference lies these concentrations are not necessarily at equilibrium, while these concentrations are at equilibrium. So this is the main difference. So this helps us to predict which way the reaction proceeds before the equilibrium is established. These concentrations are at equilibrium when the equilibrium is established. So it only takes us when the equilibrium is achieved. Whereas this reaction, it takes us whether the reaction proceeds or not before equilibrium is established. Therefore, this has more information. It provides us more information before equilibrium is established. So this is the main difference between reaction question and Kc. So you have to differentiate this. Now we'll see three scenarios. The first one is when reaction question is less than Kc, and the second will be when reaction question is greater than Kc, and when both are at equilibrium or at equal. Now, so to see which direction the reaction proceeds, I will use a line. So just put C somewhere, and then if Q is less than C, it means it is over here. So you can predict which direction it proceeds to achieve equilibrium. Because this is less than Kc, the reaction proceeds towards the reactant until an equilibrium is established. So this shifts to the right until equilibrium is established. So this is very important. So you'll be given two values, one value for Q and then for Kc. So simply you have to compare it and then tell which direction the reaction proceeds. Now, when Q is greater than Kc, so Q is somewhere over here, so the reaction proceeds to the left. Reaction proceeds to the left until equilibrium is established. So this is very important. Alright, now with the third scenario is when Q and Kc are equal. So this is simply at equilibrium. So it will not move either direction. Alright, now let us see this with an example. At a certain time, the concentration of N2O4 is 0.12 molar and the concentration of NO2 is 0.55. And if you have Kc, which is equal to 0.21, so the question will be, has the reaction reached the equilibrium? If not, in which direction it is going? And therefore, to answer this question, we will have to calculate the value of Q. Remember, Q helps us to determine which direction the reaction proceeds before equilibrium is established. Therefore, to calculate Q, simply it is the concentration of NO2 to the power of 2, because there is what? 2 as a coefficient in this case. Therefore, I have to raise to the power of 2 and then over N2O4, which is 1, therefore I didn't have to write 1 because it's already known. Now, the concentration of NO2 at a certain time, meaning before the reaction has achieved equilibrium, is 0.12 squared over the concentration of NO2 is, this is 5, and then over the concentration of N2O4, which is 0.12. Now I have to calculate this. Okay, 4.58 times 55. I have 4, I have 2, 22, 2, 0, 4, 6, 4, 2. Right, now, okay, exactly. So 0.25 is the answer. So this is the value of Q. Now we are given the value of Kc. Therefore, Q, which is 0.25, is greater than Kc. Now, what does this mean? So it has not reached equilibrium. Therefore, in order to reach equilibrium, the reaction has to proceed towards the left. So the reaction proceeds to the left until the equilibrium is established. So this is how you can tell whether the reaction has reached its equilibrium or not, simply by comparing to reaction equation. Let's proceed and see another example. So if you have A as gas, which is in equilibrium with B, now you are given equilibrium concentrations of A and B. So because these are equilibrium concentrations, you can calculate Kc. Right? Now remember, Kc is simply concentration of B over concentration of A. So we are given concentration of given, of course, we are given concentration of B, which is 1.2 times 10 to the power of minus 4 over 2.8 times 10 to the power of minus 4. Simplifying this, okay, by 4, 3 by 4, 7, 0.3, by 4, okay, 0.4, okay, 2. So this is approximately 0.42. So this is the equilibrium concentration. Now, the question is, does the reaction shift to the right, left, or not at all for each mixture to reach equilibrium? Now, once we calculated this, we will compare it to this value of Qc to determine which direction the reaction proceeds. Now, given the value of Qc, which is equal to 4, and then compare it to Kc, which is 0.42, this is much larger than the value of Kc. Therefore, the reaction proceeds towards the left. Remember, use the line just simply to see which direction the reaction was. Because this is greater than Kc, the reaction has to proceed to the left until it reaches the equilibrium. Now, alright, I think I have made some mistake. I think this should have been, alright, 4 to 1. Okay. Alright, now let's compare it to when the value of Qc is 0.67. So this is greater than this, So similarly, the reaction will proceed to the left. When QC is about 0.42, so because the value of Q and Kc are equal, now the reaction is at equilibrium, so it doesn't move or it doesn't go in either direction, not at all, because this is at equilibrium. Now the last one is when the value of Q is 0.25, which is less than Kc, therefore this reaction proceeds to the right until the reaction reaches the equilibrium. Alright, and that's all I have. Thank you for listening. Stay home and stay safe. Bye.